Hello everyone. Here's some, sorry about that. Here's some good practice with exponents and logarithms. Definitely something you'll see a lot in AP Calculus. One thing to take note of, we'll talk for a second about log of something, but 90% of the time when we talk about logarithms, we're really talking about the natural log. So we'll have a few practice problems for that. All right, so the reason exponents and logarithms go together is because in general, logarithms are the inverse function of exponential functions. So for example, if I have e to the x, I want to know that what this graph looks like. E to the 0 is just 1, and as x gets large, it's going to grow very quickly. It grows exponentially. And then as x gets small, e to the negative something will just be a fraction. So it will never become 0. Exponential functions are always positive, but it does have a horizontal asymptote at 0. Okay, so what would the inverse function of this look like? Inverse functions are they are symmetrical around the line y equals x. For every point here, for example, 0, 1 is going to have the point 1, 0. And so what would this function look like? ln, which does have the base assumed to be e, is going to be the inverse function of e to the x. This has the little bonus of a little translation to the right. So what would this look like? Instead of having a vertical asymptote at 0, my vertical asymptote is going to be at 5. And, if I could do a test point here, if I plug in 6, I'll get ln of 1, and that's 0. So this is going to look like that. It does grow up out to infinity, so don't think that there's a horizontal asymptote. There's only a vertical asymptote. Okay, so some things about logarithms. If you do see log, it's assumed to be the base 10, and a logarithm is really asking about the exponent. What exponent gets me from 10 to 1,000? And that would be 3, right? 10 to the third is 1,000. What exponent gets me to e? Well, if the base is e, then e to the 1 is e. ln of e is just 1. What exponent gets me to 1? Well, e to the 0 is 1, so this is going to be the number 0. All right, here's a little trick question here. If it was ln of e squared, then we can, with logarithm, and all the properties over here, with the properties of logarithms, you can bring that out front. And ln of e is just 1. 2 times 1 would be 2. But here, this does not exist because you cannot take the logarithm of a negative number. Okay. So here's a couple of equations that you'll need to be able to solve in AP Calculus. First thing I'm going to do is divide by 2. So now I have 6 on the other side. And there is one way to think about that, and that is to convert this into an exponential equation. But the way we mostly think about these equations are, why not raise both sides to the e? Because now I have e to the ln of something. Well, since they're inverse functions, we just get x minus 2. And on the other side, we have e to the 6th. So the answer to my equation is e to the 6th plus 2. Similarly, if the x is trapped in the exponent, first of all, we'd want to get this all by itself first by dividing by 4. Then the way to get the x out of there is by taking the ln of both sides. And that's because ln of e to the x is just x, and so x would be ln of 10. In terms of limits, it's really about knowing what this graph looks like. What's the limit from the right side? Well, there is a vertical asymptote of this function, so we're just going to say negative infinity. As ln gets close to x from the right, it goes down forever. Here's a very common thing is to have a y and an x inside. Oh, sorry, we lost track of here. Here we have y and an x inside of an equation, and we want to write this as a function. so we want it to be in y equals form. In other words, we want to solve for y. What you can do is raise both sides to the e. You can't raise all three things to the e. You raise the entire side to e, and what we're left with is 4 minus y equals, well, what can we do? This is e to the cosine of x. This plus ln of 2 is here, and I'm going to show you that if we had e to the cosine of x plus ln of 2, with the properties of exponents, we can make it e to the cosine of x times e to the ln of 2. And e to the ln of 2 is just 2. So we really can write this as 2e to the cosine of x. And let's say I move the y to this side and move this to the other side. This in function form would be 4 minus 2e to the cosine of x. All right, so I'll come up with some good practice problems for that. Good luck to everybody.